Hello, beautiful people, and welcome back to the Chem Lab. Today, we are naming binary ionic compounds again, just like our last video, except this time, we are going to include transition elements. And if you've been paying attention in chemistry class and life in general, you know that transition elements need a little extra attention because they have more than one possible charge, and we need to deal with that in the name. So grab your periodic tables, and let's get started. In our chemistry travels, we've learned that there are two main types of metal ions. Ones that have only one possible charge, in which case we're just naming the metal, and those that have more than one possible charge, those tricky transition elements, like iron, for example, can be a 2 or a 3 or even a 6 sometimes. And those get named with the Roman numeral attached to them to show which charge it actually is. It doesn't show how many of them there are in the compound, it shows the charge of that particular ion. So when we're naming ionic compounds with transition elements, we need to put a Roman numeral in the name. And that's what we're practicing today. So first, reminder that if you don't have a periodic chart of the ions, you may want to get yourself one, download them off the internet, whatever, search for it, you can find them. And it'll show you the possible charges that you can have. And sometimes, though, it gives you the most common charges. But like I said, like iron could be a 6. That doesn't show up on this chart. That's okay. Just go with what the formula is giving you, and know that it probably does exist. All right. So real quick review. We have this in the other video. To name the compounds, you need to name the metal, check to see if it needs a Roman numeral, and then use one word for everything else in the formula. So your formula or name should only have 2 words in it. All right. And examples with the transition elements. Transition elements will need a Roman numeral in the name of the chemical compound. Leave a space for it. If you recognize those transition elements, leave a space. Find the total negative charge on the anion side. So this is where we're trying to decide, well, which Roman numeral do I use? Is it the 2, the 3, the 5? What is it? You have to use the one that balances, use whatever Roman numeral you need to balance those charges. So find the total negative charge on the other side, use what you need to balance it on the left side. All right, and that can be kind of tricky, so let's get into it. Show you a couple examples. I'll let you try a couple as well. Starting with this first one, MnBr2. So I'm looking at my periodic table. I see Mn. I see it's in that middle section with the transition elements. So I'm thinking, yeah, it's going to need a Roman numeral. So let's first write the name of it. Manganese. Okay, and let's leave a spot. Manganese, by the way, is one of the worst offenders of the transition elements. It has like 5 different charges. It could be a 2, a 3, a 4, a 6, and a 7. And so it's just got a lot of different oxidation states. So we're going to put one in there, but I don't, at this point, know which one it is yet. I have a sneaking suspicion, but let's first name the other side. Monatomic anion, there's 2 of them, and that's just going to be a bromide. Bromide is right there. And so great, I need a Roman numeral now before I'm finished. So what do? I check the charge of bromide. And it turns out that bromide is a -1 charge. So I need to get the total charge on the right-hand side. So it's -1, but there are 2 of them. So make sure you note how many there are. And that makes it a total of -2 charge overall. That means the left-hand side has to be a +2 charge overall. And so that tells me that the manganese here is the +2 version right there, and not the 3, the 4, the 6, or the 7 that manganese can possibly have. So manganese 2 bromide. Let's try another one. We have the element nickel. All right, and I recognize it as a transition element. It needs a Roman numeral, so leave a space for it. And then I go to the other half. Now the other half is just one element. Again, it's going to end in IDE, so we'll put oxide. Okay, now to balance the charges, there's a couple of ways to do it. The first is to look at the charge of oxide, and that's a -2 charge. Okay, and you have to get the total charge for each side. So -2 times 3 is actually a -6 overall charge. Okay, and that means that the cation side has to be equal to a +6. Does that mean that I put a nickel 6 in this parentheses? Well, no. Nickel actually doesn't make a +6 charge as far as I know. But I do notice that there are two of them. So 2 nickels have to add up to +6. And that means that each nickel then is going to be a +3. Nickel 3 oxide. All right. Are you ready for this? We have 2 more. This is our pause the video moment. Look at your periodic chart and your materials and see if you can get these last 2. And I'll meet you back here in a couple seconds. All right. And if you came up with platinum 4 chloride and titanium 3 fluoride, then congratulations, you've mastered this little section using binary ionic compounds and with transition elements. So good job on that. And I hope you found this helpful. If you have any questions, you can send them to me. And in the meantime, happy studying and have a great day.